Hello, and welcome to this demo, which will show several technology building blocks that help to provide technical assurance for confidential computing using SUSE Linux Enterprise Server on IBM Z and LinuxONE systems. My name is Mike Friesenegger. I am a solution architect at SUSE, working on the global partnership with IBM. The TUT 1034 session, titled Confidential Computing with SUSE and IBM Z, showed a couple of screenshots during the presentation. Instead of seeing screenshots, you'll be able to watch the demos in action during this short session. The following demos that I will show are using YAST to enable pervasive encryption for data volumes and showing secure boot on an IBM Z15 LPAR. I encourage you to watch the TUT 1034 session where Adam Jollins of IBM and I explain in more detail how IBM Z and LinuxONE systems can be used to provide technical assurance for confidential computing for on-prem as well as in the cloud. So now let's dive into the first demo using YAST to enable pervasive encryption for data volumes. So we're going to start on this system, and the first thing we're going to look at is the crypto card and the hardware security module and the domains that are associated with it. You can see domains 1, 4, and 5. I'm going to look at the verification key for domains 1, 4, and 5. And you can see that the verification key for 1 and 4 are going to be the same, the VER, but the verification key for 5 is different. And this is important as we get a little further along in the demo. Now let's go ahead and start YAST. And I'm using the GUI-based version, or the text-based version of YAST versus the GUI-based version of YAST, but they look very similar. They work very, very much the same. I'm in the partitioner. I'm going to go ahead and configure some additional DASD devices, 151 and 152. This can work with SCSI as well, but I'm using DASD. I'm activating the DASD devices. They're relatively small. As you can see, 1.53 gigabytes. They're DASD B and DASD C. I'm going to go ahead and create a partition on these devices, and I'm going to put them into a logical volume, a Linux LVM. All of this is pretty common, except now I'm clicking on encryption, and as you can see, I'm selecting the encryption method, which is pervasive volume encryption. The encryption password is actually the passphrase for the LUX2 header, and I selected just domain 1 and 4 of the hardware security module. I just finished DASD-B. I'm going to repeat this for DASD-C, so if you missed it, I'm going to run through it one more time. You're going to see selecting pervasive volume encryption, putting in the passphrase for the LUX header, and now I'm going to select the APQN 1 and 4 because they have the same verification key. 5 does not. Now that I've specified the partitions on DASD B and C, now I'm going to go to the volume group management, which is standard stuff in YAST. I'm going to create an ENC volume group. I'm going to add both partitions to that volume group. I'm going to go in, and now I'm going to create a logic volume called ENCLV1. And again, I'm going to make it small. Actually, I'm going to set a custom size of 1.5 gigs. So it's just really small, just to demonstrate the pervasive encryption. Now I'm going to go ahead and leave it as formatted as an XFS file system. I'm going to set the mount point to ENCLV1. And that's it. Now I'm going to go ahead and view the changes to the partitioning and let YAST do all of the work. You could do all of this manually. IBM has great documentation. We have great documentation how to do the command line. But what I really like about YAST is it does it all for you. It sets up all of the work with the hardware security module. It does the logical volume management work. It creates the partitions. It takes care of all the mounts and all of that. As you can see, it's mounted. We're going to go ahead and write something to this encrypted logical volume setup. And as soon as I write the word hello in that file, it's immediately encrypted at CPU speed because of utilizing the CPAC F functionality on the Z processor. Now we're looking at Z key, which is something that you would have to do manually, and you'd have to know all the parameters. You'd also have to work with crypt setup command, which you don't have to do. YAS takes care of all this for you. The other thing that YAS does is it makes sure that when you reboot the system, it sets up the keys properly to allow the system to reboot and not require you to input the passphrase to unlock the LUX header. And as you can see, I can go ahead and access the hello file, and we are good to go. All right, let's move on to the next demo, which is showing secure boot on an IBM Z15 LPAR. So now we're on a Z15 LPAR, whereas before I was on a Z13, and just do a UNA-A to show that it's an S390X architecture. The I'm going to CAT-sys firmware IPL has secure. That tells me that the Z15 that we're running on a Z15 or an IBM Z system that has the ability to support secure boot. And the second one, IPL/secure, tells me that this SLES has been booted securely. We can look at the D messages and grep for the word secure, and it also shows that it was securely IPL, it was enabled, and it recognized the SLES secure signing key. Now we're going to switch gears to the hardware management console, the way to look at the LPARs that are on this Z system. I have access to two LPARs, ZE1 Charlie and ZE1 David. We're going to go ahead and load ZE1C, and I shut it down. Now I'm going to go ahead and enable it, or I'm going to load it, but I'm going to disable the secure boot option. Hopefully you saw that very quickly. We're going to go ahead and finish the task of starting up the LPAR. And the LPAR is in the process of starting. We're going to go and look at the operating system messages, the boot messages. So once the load in progress shows success, which it now does, I'm going to switch to the operating system messages screen. And here in a moment, we're going to see some familiar messages. We're going to see, well, let's wait just a moment. There it is. You'll see grub booting up. Now this is SLES booting on an IBM Z15 LPAR using SCSI disks, and you can see SLES 15 SP2 is being loaded. Now I'm going to go ahead and open up the ASCII console, the HMC ASCII console, and you can see in the background the boot messages are showing. And as soon as it gets to a certain point, we will see the login prompt on the ASCII console. There we go. All right, so the system is booted back up. Let's switch over. Let's SSH back into that system from our terminal. And SU to root. And let's just look at the secure boot. So are we running on a secure system? Yep, it has secure. Yep. Did it boot up securely? In this case, it shows 0 or no. So this time the system is booted unsecure, and you can see the secure IPL is disabled, even though it noticed that the secure boot signing key is SUSE Linux Enterprise Server. So with that, I'd like to say thank you for watching this short demonstration, and hope the rest of your SUSECON is going well. Bye-bye.